So folks, today we've got one of the sets that Alan kindly passed on to me. Alan, our mystery benefactor. And this one's the Midland 3001. Could probably do with some of that famous RAL whatever it was paint that we worked out. So it's a March 1982 one. It's the original kind of year, but it's a little bit later. It's not a November one. Comes with a bit of a power lead and some banana plugs. So you're probably aware they do the 4001 still for the Italian market. It works out about somewhere around about £250, and the innards is, if I recall, is the same as the Midland 48. So, you know what? I know that's a lot of money, but if they actually did it for the Euro market as a multi-norm, and if it's got the Midland 48 innards, you know, I'm sure that wouldn't be difficult to achieve. They would sell them at 250 quid. For those of you with the Bank of England calculator, these were £79.99 at the time. So in 1981, £79.99 was of course worth more than it is today, isn't it? So we'll open it up. I better put the soldering iron on because the speaker's going to want detaching. We've got a original mic. It's a bit faded like they go, but it has survived. Right. Is that it? It is it. So all we need to do is to try and get the lid off. I'll go and get a sheet and we'll write down its parameters. And there's a good word for a Thursday. One day I'll find out where the clipboard's gone. I expect Mr. Chippy's nicked off with it. So a lot of you will be aware this chassis used in this was using an awful lot of Maxon made South Korean sets at the time, like the Maxcom 4E, 6E, Cobra 19, Cobra 21 XFM, Cobra Colt 295, 295A, Comtron 40, and so on. So what I'm just looking at initially is, have we got a situation with any capacitors that look distressed? Now, in the 40 years I've been working on two-way radio, I think we've only had one situation where capacitors actually caused the fault, though I have changed one or two within my diagnosis. I'll just tip that out. It's a case thing. Right, we'll get that connected up. He did tell me this was a worker, and so I'm going to be interested to see how well it works. Right, there we go. So start with the, what's it, 8053371. 8053371, Midland 3001. It's the 31st of August 23. And if I can manage to do this in 40 minutes, we can on the air test it today. Power it up, switch the solder, helps to put the power supply on, doesn't it? So it's lit up. It was on channel 19. now on channel 20. This is the meters fade on these if they're left in the sun. We'll put picture in picture on. We'll go into transmit. I'm on the 3 watt scale, and it's bang on 3 watts. Okay, so we'll go to a different channel, like channel 40, and it is 2.8 watts. And go to channel 1, and it's 3 watts. So back to channel 20. Current consumption 982 milliamps. And they don't have low power, which wasn't strictly legal. Plustronics would have had to modify the sets if they were so asked to by a customer, and they'd have had to do that for free. So, deviation. Wallow. About 1.8 possible. I'll tell you what we're going to do. I'll go straight over to the test set behind me, seeing as we can't trust always what this one says. I need that second opinion with the test set behind me. Wow, it's absolutely spot on. So we've got a peak of 2.5, it's averaging 2.2. So that's one parameter, which we're not going to do the VCO. You have to add some extra parts in to do that. The way they set these at the factory, it's done on a pin jig, and they don't need all the parts. But you can add about 4 parts in to be able to check the VCO. We don't need to do that. Right, let's go to the frequency counter and see if it's anywhere near on frequency. 79058. It's not quite out of spec, but it starts to become noticeable. I may as well do that right now, and then it saves us having to tune the receiver with the signal generator off. That's the wrong way. That'll do nicely. So I haven't got a knackered crystal yet after 40 years. So the RF meter, I'm going to tick that off as working right. I'm going to have to really look at that very closely. So we're going to say that's okay for now. And the meter lamp's lit. We're going to check it on public address. While I'm plugging things in the back, we will plug in the instrument test speakers. Okay, so we're on that. We have that filter. Keep it in the treble side. We'll go over to PA. Testing 1 2 3 1 2 1 1 2 3 1 2. So that works. So everything works. Mic works. I haven't tested the speaker. Right, so let's put in on the signal generator 2779125. Try and make this the quickest tune-up we've ever done. Because yesterday we were on CPT, so to mess with the signal generator, didn't we? There we go. So without any adjustments, let's just see what it's reading on the sine nav meter. To say that right, Poltergeist has adjusted that. So where are we? Oh, that's all right. So for 12 dB, got 0.78. Anything on 1 and under is absolutely fine on this chassis. They're not as sensitive as some sets, but they're very competent, very reliable. 0.73. And for 20, if it will do it, it's 1.5. Squelch threshold. .79 and squelch to full never opens. So that wants addressing. Right, let's get on with a tune-up. So on transmit, let's go over to the main meter. We've got a Midland 4001 coming. It's in about 10 sets time. So we did the 2001 not long ago. So we've got this today, and perhaps in about a couple of weeks we'll have a 4001 to do. So I'll go over now to the other scale. We're now on the 30 watt scale. Make sure we are on channel 20. Yes, we are. That was slightly out. Yeah, I mean, to be honest, it's just a non-messed with one, isn't it? It just kind of, apart from the deviation, has been upped a little bit, and the squelch, it's not really had the golden screwdriver in it. So at the moment we're spot on the 4. I'm just going to recheck this one. Okay, so on channel 20 we've got 4 watts. Let's have a look at the other channels. I like them to be within 0.1. It's not always possible. 3.8 on channel 40. And on channel 1, it's 3.95. So it's never going to, I wouldn't be able to balance that any better. We could probably get 3.9, 3.9 and 4, but that's fine, absolutely fine. So that's got 25% more power, hasn't it? Now that's going to take some more electricity, so we'll now see what it's drawing. It's 1.09 amps. So deviation we didn't need to touch. Deviation is that preset if we did need to adjust it. So now we'll do the power preset. Which is going to be that one if I remember rightly without looking at my notes. So just back that off again a bit, seeing as we've upped the power. So that's that. So now we'll move over to receive, which is already excellent. A bit of noise on that volume control, we'll give that a spray. Whether or not we've got a service or with an applicator is another question. We'll have to go and raid Mr. Chippy's domain for that. Okay then, so we'll go to start with the detector. 100 microvolts on the signal generator, and this is a chassis that can drift on the detector. A bit more volume on. Yeah. There we go. So that will have improved the clarity, but it might have knocked off the sensitivity, but that's how it has to be. So now we'll go to the cyanide meter. Overshot that, didn't I? There we go. So wow, it's a massive improvement. So that'll nicely compensate for the fact I've adjusted the detector. And that's an improvement too. Let's go back to that one because they are interactive. Yep, it's fine. Wow. So the IF ones were that was spot on. That was just about spot on. The two front end ones were a little bit out, and the detector was. So, before we reveal what the readings are, let's go to an S9 signal of 100 microvolts and see what the meter reads. So it's adjustable on this slightly later on it with that preset. So it would be about I should have written it down, it'd be about 120 because I just moved it that bit. Okay. So now we'll do the squelch. So I'm going to put the squelch to full. We've got this test equipment at 100 microvolts. Put the attenuator on the screen so you can see. So we've got 0 and 100 microvolts, and I need to adjust the squelch until it just opens. And that's now how I want it, 100 microvolts. So tight is 100 microvolts. So let's read what it's doing at its most sensitive points. We'll turn the squelch down on the radio. Signal generator is on standby. Set the threshold on the radio. Signal generator back on. We've now got 0.57. That's a very nice squelch. Mind you, it was as it was on the lower side. I mean, some of those team radios are 2 and 2.5, which is ridiculous. You know, you can't squelch out scratchy corner properly. So let's see what the sensitivity is. So we'll go back up to the cyanide meter and move it again. One day I'll reset this. I don't know why they move. Must be the mice in the loft. So for 12 dB, got 0.55. For 10 dB, got 0.49, and for 20 dB it's 1. So apart from putting some spray on there, we're done. I'll go and see if I can find one in Mr. Chippy's domain. Well, I did find one with the applicator. Let's solve that problem. He's already done the power socket, that's clearly been changed. So it was, you know, when you look at those figures, it was receiving quite nicely. Certainly better than a lot of sets do. And now it's even better. So it's a good example. It's clearly well used. And you can see the bezel's been brush painted at some time. Right, we'll see if we can get the screws back in, which do look to be the original ones. They're the silver screws. Unplug the extension speaker, as in the instrument speaker. Yeah, it's working on the internal one. Unplug the PA speaker. Put the final 2 screws in. And that is what happens when you have a set that just needs a retune and test. And it's probably 40 minutes, which is why our sessions are actually designed to be 45 minutes. We're still doing that the DNT base station, you know, the DNT B40. We are waiting for a part from China. So don't think you've forgotten the part 2 where we finish that off. Good. Right, we'll put the aerial in and we'll see if there's any good or bad buddies out there. I've got my radio ham friend who I worked with for many years at Nottingham Radio coming this weekend, Mark G7 and DJ, so he's actually coming today, so there you go. That needs to go in there better, so I'll do that behind the scenes. That sleeving's actually out of the clamp. One on a Roger. They won't hear me, will they? Because they're all on burners. So for those of you who don't know the way these work, filter is a tone controller. Bass here, treble, bass, treble. That's all that does. CBPA is obvious. Now the RF gain, when it's in DX mode, that does nothing. When it's in local, that does do something. You might just see the meter move, whereas in DX it doesn't. So it stays in DX unless we want to use the RF gain. That has the advantage that you might find, you talk to somebody like in a convoy, and they're just in the car behind you, you'll have that to absolute minimum, and then when you're in that situation you would just flick to local, so it's instant. So I can see why it's done like that. So there we go, put it on channel 31, Tango 21 test. There we go. Right, so we're done on the air test. So thanks once again to Alan for so kindly letting us have that radio, and we'll do an on the air test pretty shortly. Thanks for watching.